Today's lesson is I can solve quadratic equations by finding the square root, and we're going to start with a bit of a review. I want you to remember that anything squared is you take the base, in this case it is 5, times itself however many times it says. So 5 times 5 is 25, and the inverse of squaring is taking the square root. So we could take the square root of 25 to get 5. And you need to have this skill to be able to do what we're doing today. So just a little bit of a review with vocabulary. For this, the whole thing is called the radical. Underneath, whatever is underneath, is the radicand, and this is called this radical symbol, although I usually say square root. We have learned in the past that all positive real numbers have two square roots. The principal square root, which is the positive one. So if there isn't a symbol in front of it, then it's the positive. Just like if there's not a symbol in front of the number, then we assume it's a positive. So the positive square root or principal square root of 25 is 5. And the negative square root, if you're taking the negative square root, there'll be a negative in front of it, and it's negative 5. And the reason this is true is because 5 times 5 is 25, and negative 5 times negative 5 is also 25. We have also talked about rational versus irrational numbers. So numbers whose square roots are terminating decimals. Terminating decimals are perfect squares. So examples of those, 25, we just talked about that. It's a perfect square. 100, 144, anything that you can find that perfect square root. So the square root of 25 was 5 and negative 5. The square root of 100 is 10 and negative 10. So you can find those numbers when you take the square root, they're terminating decimals. Irrational numbers happen to be non-terminating and non-repeating numbers. So here these terminate. Irrational numbers do not terminate, do not end, and they don't repeat. So you cannot have 0.3333, etc., etc., etc. That is not an irrational number. The most famous irrational number is pi, because it goes on and on and on forever without repeating. So 0.321486, etc., etc., etc. Not repeating, not ending. Numbers that are not perfect squares are irrational numbers. This vocabulary is really important, especially for standardized tests. So irrational numbers, not perfect squares. All right, let's get to the main lesson. We're going to be talking in this unit all about quadratic equations. A quadratic equation is an equation that can be written in the standard form ax squared plus bx plus c equals 0. So a, b, and c are the real number coefficients, just like we had ax plus by equals c for standard form for linear. This is the standard form for quadratic equations. A is still the leading coefficient, but the difference between linear and exponential is now our exponent is 2. So the highest exponent for a quadratic equation is 2. So here, are they quadratic? Is this one quadratic? Yes, it is, because if we rearranged all of this, we could fit it in this, and my highest exponent is 2. Is this one quadratic? No, because I don't have an x squared in it. And I certainly could rearrange it and have a as 0, so 0x squared plus 4x plus 18. But to be a quadratic, a cannot be 0. So the coefficient of the x squared cannot be 0. Is this one quadratic? X squared plus 8 equals 24? Yes, because we could do x squared plus 0x plus minus 24 equals 0. In other words, b can be 0, just not a. As long as it has an x squared in it, it is quadratic. Unless there is a higher exponent like this one. So here's my x squared, but there's a higher exponent, so this one would be no. So yes, yes, no, no. So you solve quadratics just like you do a linear using inverse operations until you get the x squared on a side by itself. And once you get the x squared on a side by itself, the inverse of squaring is taking the square root. So we have to take the square root. So we have the square root of x squared is x, the square root of 4. Because we wrote the symbol in, we wrote that radical symbol in, we don't know if we're talking about the positive or the negative. So we have to put both the positive and negative square root of 4, which is 2. So again, because we wrote this symbol in, we don't know if we're talking positive or negative. So the square root of 4 is 2 and negative 2. So second example, we are going to use inverse operations to get that x squared on a side by itself. Divide by 3, so x squared is 16. The square root, since I'm writing in that symbol, showing the opposite of squaring is taking the square root, it's going to be both the positive and negative 4. And don't forget to check by plugging back in. Alright, so I'd like you to pause right now and attempt these two problems, see if you can do them on your own, and then check back to see if you got it correct. Alright, so I'm wondering if you ended up with the same thing I did here. So I subtracted 45, and then I divided by 5. But right here, we've talked in the past about how you cannot find any number that when multiplied by itself, it gives you a negative number. If you put -3, -3 times -3 is a positive 9, not a negative 9. So remember, you can't find the square root of a negative number, so it is a no solution. Unless we start talking imaginary numbers, which I do have a tab in Blackboard on imaginary numbers, you will probably see it on the map test, so I'd take it out. I'd check it out. But for right now, we're going to say this is a no solution. This one was pretty straightforward until you got to right here. Yes, decimals are okay in real life. And this is approximately, because we had to round, the square root of 3.75, that's an irrational number, so we had to round to 1.94. So again, we know that 0 has only one square root. The square root of 0 is 0. And negative numbers have no square roots, and so we've already talked about why. So we say it's undefined or no solution. So we can use this to check our answer. So when you're solving quadratics, you can check the number of solutions you should have by remembering positive numbers have 2 square roots, negative numbers have no square roots, and 0 has 1 square root. So once you get the x squared on a side by itself, let this guide you. This is another way to think of it. X squared equals d. D is positive, so it has 2 solutions. X squared equals negative d. You can't find a square root of a negative number, so it has no solutions. And x squared equals 0 will only have 1 solution. So a couple of trickier examples. Here, I want you to remember that the base is whatever is right in front of the exponent, so this is your base. This is what you have to get on a side by itself. And once you do, you can solve by taking the square root of both sides. So the square root of x plus 3 squared is x plus 3. And the square root of 16, remember, is both a positive and negative 4. So really, you have 2 different solutions. You have to take x plus 3 is 4 and solve from there. And you have to do x plus 3 equals negative 4 and solve from there. So in this case, x would be 1 and negative 7. All right, this one is not quite as tricky. You're just using your inverse operations, but I wanted to remind you about if the coefficient is a fraction. If it's a fraction, remember you multiply by the reciprocal. So in this case, we're multiplying by 2. So I have x squared equals 10 The square root of 10 is an irrational number. So I know we're going to have, but it's positive, so we're going to have two solutions. But we're going to have to use a calculator to find the square root. It's approximately 3.16. There are going to be times soon where I ask you to leave it in radical form. If I left it in radical form, it would be both positive and negative square root of 10. There are actually many real-life situations that use a quadratic to solve, and the formulas are usually given to you. And in this case, this is a formula for how to find an object from height s, how long it takes to reach the ground. So h is going to be the ending height, where you want it to end up, where s is the beginning height, where it started, and t is the time in seconds. That negative 16, that's the same, that's part of the formula. So I did not come up with this formula, but this is the formula that is used to find, again, how long it takes to reach the ground if it is dropped. Not thrown, dropped. So you just plug in your numbers. In this case, because we're wanting to know how long it will take dropped from height s, and in this case 2,000 feet, height s, how long it will take to get to 0. So the tricky part is it says h is 2,000 feet, but really that's the height at the beginning. The height at the beginning is s. So this 2,000 feet is going to go in for s, and we want to know when it reaches the ground, so that will be height of 0. So you plug in 0 equals negative 16t squared plus 2,000, and then you solve from there. So take a moment and solve. All right, solving it was just solving like normal using inverse operations, but because this is an application problem, the time, we can't have negative time, so we're not going to have the negative of this, just the positive, and so the time is approximately, because it was an irrational number, 11.18 or 11.2 seconds would be your answer.